Hey everybody, welcome to section 8.5, part 2. We are going back to chapter 8 for a moment because we now have an easier way of graphing quadratic equations when they begin in standard form. Because we've learned enough in chapter 7 that now we can use the factoring techniques we've learned to be able to convert between forms in order to make the graphing easier. So notice that you'll need a piece of graph paper for your notes for this lesson. So I want you to pause the video, get a piece of graph paper, and then set up your note sheet with the section, the date, and the I can statement, and then resume the video as soon as you are ready. All right, so back in chapter 8, we learned three forms of a quadratic equation. I'd like you to pause the video and see if you can write down the name of each form that I've got here, and then next to it, I want you to see if you can remember the three forms. And then resume the video when you're ready to compare with me. All right, so standard form is y equals ax squared plus bx plus c. Factored form, y equals a times x minus p times x minus q. And then vertex form is y equals a times x minus h squared plus k. So today we're going to learn how to convert from standard form into factored form in order to make the graphing easier. And this is something you now know how to do because you know how to factor quadratics in standard form using either sum and product or box and diamond or the split method. Later on in chapter 9, we'll learn how to convert from standard form to vertex form as well, but we need some more algebraic knowledge in order to do that. So let's go through a couple examples here. So our first example, our goal is to graph the function y equals x squared minus 8x. And this is something we did back in chapter 8, but now we're going to do it easier and also more accurately by factoring to get the x-intercepts as well. So our first step here for each of these problems is we want to convert to factored form. And to do that, we're going to use our techniques from chapter 7. So for example, for this problem, the first thing we're going to do is factor out the GCF. So in this case, we would have y equals x, because that's our GCF, times x minus 8. And because there was no c term in this problem, that's it. That's our factored form, x times x minus 8. So in step 2, we're going to find and plot the x-intercepts. So for this problem, our two x-intercepts would be x equals 0 and x equals 8. And we can think of those as points, right, because they're x-intercepts, so 0, 0, and 8, 0. So I'm going to find and plot those two x-intercepts. I'll put 0, 0 on my graph, as well as 8, 0 on my graph. And then step 3 is we did this in chapter 7 as well, but we need to find the axis of symmetry. And to do that, there's two ways to do that. One is we know it's halfway between the x-intercepts, so in this case it has to be 4. But if you're not 100% sure, remember that it's the average of the x-intercepts. So the axis of symmetry, you take your two x-intercepts and add them together, and then divide by 2, and that gives you your axis of symmetry. So I'll put that in here as well. So 2, 3, 4. So that gives us our axis of symmetry. And then step 4 is we need to find and plot the vertex. In this case, the vertex has to be on the axis of symmetry. So to find the vertex, we're plugging the axis of symmetry back into the original equation. So the original equation was y equals x squared minus 8x. So I'm going to go everywhere where I have an x, we're going to put in 4. So in this case, because 4 is our axis of symmetry. So y equals 4 squared minus 8 times 4, which gives us 16 minus 32, which is negative 16. So in this case, my vertex, well, I'm a little off my graph here, but my vertex would be right down here at negative 16. And then I can come in and draw in the lines to plot my function. So this is how you graph a quadratic equation in standard form by first converting it to factored form. And what this does, it gives us a more accurate quadratic equation because now we have the vertex as well as the two x-intercepts. So let's look at another example here. This one is going to be in standard form, including the c term this time. So if you would like, you could pause the video and try this one on your own by converting to factored form and then plotting the x-intercepts, the axis of symmetry, and the vertex. And then you can resume the video as soon as you're ready and watch me do it to make sure that you got it correct. All right, so the first thing I'm going to do is convert to factored form. So step one, convert to factored form. In this case, we are in standard form, and our a term equals 1. So that means I can use the sum and product method. So I'm going to look here and say, okay, my sum has to be 6. My product has to be negative 27. So I need two numbers that multiply to negative 27 but add to 6, which in this case is 9 and negative 3. So my new factored form would just be x plus 9 times x minus 3. So that's the conversion. And then for step 2, we just need to find and plot the x-intercepts. So in this case, x equals negative 9 and x equals 3. So my x-intercepts are at negative 9 comma 0 and 3 comma 0. So I'll put those on my graph. So negative 9, 0, and 3, 0. So then step 3, we need to find our axis of symmetry. And the axis of symmetry, remember, is the average of the two x-intercepts. So x equals negative 9 plus 3 divided by 2. In other words, it equals negative 6 over 2, which is negative 3. So I'm going to put in my axis of symmetry at negative 3. And then finally, we need to find our vertex point, which means we're plugging negative 3 back into the original equation. So y equals, everywhere where I see an x, I'm going to put in negative 3 instead. And then we just need to simplify this a little bit. So we have 9 minus 18 minus 27. So in this case, our vertex is at negative 36. So, you know, and I probably should have maybe chosen a better example here, but I'm just going to put negative 36 down here. You could always use units of like 2 or 4 on the y-axis to make it all show up and make your graph fit a little bit better. But then I'll draw in my quadratic function, and I'm just going to label my vertex because it's kind of hard to see here. So we're at negative 3 comma negative 36 as our vertex point. So this is how you convert from standard form to factored form and then graph your quadratic function using that new knowledge that you learned in chapter 7. When you do your homework tonight, make sure you use graph paper, but also make sure that you do the problems from chapter 8.5. So make sure you're looking at 8.5, not something in chapter 7. So good luck on the homework, and let me know if you have any questions.